So, if you clicked play today and thought, wait, welcome to the Funeral Channel Network podcast, don't worry.
Yeah, you are definitely still in the right place.
Right, this is still your custom deep dive.
Okay.
But I mean, we are getting into something today that is, well, pretty intense, but also incredibly fascinating.
Oh, absolutely.
Because right now, beneath the streets of pretty much every major city, there's this massive invisible infrastructure of heavy-duty gas lines.
Yeah, a huge network.
Right, and a really surprising portion of that infrastructure is dedicated to just one ancient purpose, which is maintaining localized furnaces at like 1400 degrees Fahrenheit just to burn the dead.
It's something you never really think about, as you're walking down the street.
Exactly. For over a century, intense fire has just been our default alternative to burying loved ones in the ground.
Right, it's either the earth or the fire. That's the baseline.
But what if the future of our final goodbye doesn't involve fire at all? What if, instead of an inferno, the most scientifically advanced, environmentally sustainable, and even emotionally comforting choice is, wait for it, a warm, pressurized bath?
I mean, it sounds totally counterintuitive at first, right?
It really does.
Replacing fire with water to get essentially the exact same physical result. But we're stepping into an area where highly sophisticated thermodynamics and, well, clinical chemistry really intersect with some of the most profound, deeply personal, emotional experiences a human being can go through.
And that intersection is basically our entire mission for this deep dive today. We are exploring a rapidly growing process called aquamation.
Yeah, aquamation.
And our roadmap for this, the source we're pulling from, is this highly detailed educational guide titled The Science of Aquamation: How Water Becomes a Gentle Return.
It's a great piece.
It is. It's provided by an organization called the Funeral Program Site. They specialize in funeral education and compassionate guidance. And the material they've put together here, I mean, it completely upends everything you think you know about what happens after we die.
It really reframes the whole conversation.
It does. We are going to unpack the actual mechanistic chemistry of how water dissolves organic matter and why urban centers are desperately hoping this replaces flame cremation.
Not to mention the surprising psychological shift families experience when they choose water over fire.
Right, but we also have to tackle the massive logistical and infrastructure hurdles because, well, if this technology is so clean and so effective, you'd think it would be available on every corner, right?
You really would. But the reality of navigating, ancient state laws, municipal wastewater bureaucracy, and just the heavy inertia of the traditional funeral industry, it reveals why it's still, honestly, a rare find in many regions.
So, okay, let's start with the language here because there is a serious rebranding effort happening.
Oh, definitely. A huge one.
The guide refers to the process as aquamation or water cremation, which, I mean, sounds incredibly soothing.
It does.
But the actual clinical scientific term for what is happening inside these machines is alkaline hydrolysis.
Alkaline hydrolysis, right.
And frankly, alkaline hydrolysis sounds like a hazardous waste procedure.
It sounds pretty intimidating.
It sounds like something involving people in hazmat suits.
Right. Well, the contrast between the clinical name and the marketing terminology is just a fascinating study in human psychology.
I bet.
Because alkaline hydrolysis, it just describes the literal chemical mechanism,
Yeah.
right? Using a highly alkaline solution to break chemical bonds through the introduction of water.
Okay.
But if you sit down with a grieving family who, say, just lost their grandmother, and you present them with a contract for alkaline hydrolysis,
Oh, man.
right?
Very.
They're going to picture a cold industrial laboratory. You immediately trigger this intense defense mechanism.
Because you strip away all the humanity. It sounds brutal.
Exactly. But when you present the exact same chemical reality as aquamation, you frame the science within a human experience.
Right.
You aren't changing the chemistry at all.
Yeah.
You're just changing the psychological entry point. And when we actually break down the science of alkaline hydrolysis, it isn't some dystopian laboratory experiment.
Okay, so what is it then?
It is simply a highly calibrated, technologically optimized version of what the Earth already does.
So it's essentially biomimicry.
Exactly, biomimicry.
Because the guide lays out that the human body is roughly 60 to 65% water anyway.
Right.
So rather than fighting the body's natural state with an external destructive force like 1400-degree fire, this process uses the body's own foundational element to facilitate its breakdown.
Yeah, let's look at the actual mechanics of how it works.
Hmm.
So the body is placed into a specialized, sealed stainless steel vessel.
Okay, stainless steel.
Right. The system then introduces a mixture, and this is typically about 95% water and 5% alkali.
And what is the alkali?
That alkali is usually potassium hydroxide or sodium hydroxide,
Okay.
and this brings the pH level up to around 14.
Wow, so extremely basic. We are at the absolute opposite end of the spectrum from an acid here.
Exactly the opposite. It is not an acid bath.
Right.
And once that highly alkaline solution is in the chamber, the system applies heat, usually around 300 degrees Fahrenheit.
Okay, so it gets pretty hot.
It does, and it also applies significant pressure. And this is crucial because the pressure prevents the water from boiling.
Oh, I see.
It allows it to stay in a liquid state at temperatures way above its normal boiling point.
So it operates a lot like a highly calibrated, pressurized slow cooker.
Yeah, that's a great way to think about it.
Just like how a commercial pressure cooker breaks down, tough connective tissue in a kitchen by forcing heated liquid deep into the molecular bonds of the material. This machine uses heat and pressure to systematically unspool the complex proteins of the human body.
That is the perfect mechanical analogy.
Mm.
Because in chemistry, what we were talking about here is cleaving peptide bonds.
Cleaving peptide bonds, okay.
Right. The heat, the pressure, and the high pH environment, they all work together to systematically dismantle the body's macromolecules.
Got it.
Fats are broken down into soaps, which is a process called saponification.
Saponification, wow.
Yeah. And proteins break down into basic amino acids. Carbohydrates break down into simple sugars. Even the DNA and RNA completely unravel.
Which means the resulting breakdown isn't just thorough, it is totally, fundamentally sterile.
100% sterile.
I was reading about the history of this process, and alkaline hydrolysis isn't new at all, is it?
Not at all.
It's been utilized in the medical and scientific communities for decades, specifically because it is so ruthlessly effective at neutralizing pathogens.
Yeah, if you look back to the outbreak of bovine spongiform encephalopathy.
Oh, mad cow disease.
Exactly, mad cow disease.
Hmm.
In the late 20th century, scientists faced a massive problem with that. The disease was caused by prions. Prions, right? Which are incredibly resilient misfolded proteins.
Mhm.
I mean, prions can survive massive amounts of radiation.
Wow.
They survive traditional chemical disinfectants, and they can even survive the high temperatures of standard incineration.
Wait, really? So if you burn the infected tissue, the pathogen could theoretically still be present in the ash?
Yes, that was the big fear. But alkaline hydrolysis destroys prions.
Whoa, wow.
The process completely unravels that protein structure, so it renders the pathogen totally inactive.
That's incredible.
It is.
Right.
So universities, veterinary schools, high-level biomedical research facilities, they all adopted this technology because it guarantees absolute sterility.
Right.
Because, I mean, when a process can dismantle a prion, it easily handles any standard virus, bacteria, or pathogen present in human tissue.
Okay, let's unpack this. So the science is incredibly rigorous, proven, and totally sterile.
Yes.
But to understand why this is becoming such a massive movement for everyday families, we have to look at the environmental thermodynamics.
Oh, this is a really big deal.
Because the contrast between this water process and traditional flame cremation is just staggering. We touched on the 1400-degree heat of a traditional crematorium furnace earlier, but let's quantify that.
Yeah, let's do the math.
The energy required to maintain an inferno capable of vaporizing human tissue for 2 to 3 hours is massive.
To put it in perspective, a single traditional flame cremation uses roughly the same amount of fossil fuel, usually natural gas, as driving an average car 500 miles.
500 miles?
Yeah.
For one person?
Yes, for one single cremation.
That is wild.
And it's not just a depletion of natural resources, you know. It is the immediate atmospheric result of direct airborne combustion.
Right, the smoke.
Exactly. When you introduce organic material to 1400 degrees, the soft tissue doesn't just vanish into nothingness. It undergoes a phase change.
Okay.
It vaporizes into gases, primarily carbon dioxide, and microscopic particulate matter.
And all of that has to exit through a smokestack.
Right into the air.
So if you live in, say, an apartment building in a major urban center, you are likely breathing in localized particulate matter and greenhouse gas emissions from a neighborhood crematorium without even realizing it.
You absolutely are. Now, traditional cremation facilities are highly regulated, but there are still point source polluters.
Yeah.
Now look at the thermodynamic footprint of aquamation. We are heating a volume of water to roughly 300 degrees and maintaining it in an insulated pressurized vessel.
Right.
The energy required to do that is a tiny, tiny fraction of what is needed to generate and sustain open flames at 1400 degrees.
Plus, the entire system is closed, right? There is no smokestack.
Zero direct airborne emissions. None.
Wow.
There is no carbon dioxide being forcefully generated by combustion and pumped into the sky. Studies consistently show that aquamation reduces greenhouse gas emissions by up to 90% compared to flame cremation.
90%, which is a monumental savings when you scale it up.
Yeah.
If a state of millions of people shifted even 20% of their end-of-life care from flame to water, the localized air quality improvements and the reduction in natural gas dependency would be massive.
It fundamentally changes the environmental legacy of our final act.
But this naturally leads to a major physical question.
Okay.
If there is no fire, and we are just dealing with water, heat, and alkalinity dissolving the body into its basic amino acids and sugars, what actually comes back to the family?
Ah, right. The ashes.
Because the entire cultural ritual of cremation revolves around receiving an urn of ashes. Do families who choose aquamation even get ashes?
They do, but to fully grasp what they are receiving, we really need to correct a widespread misconception about what human ashes actually are.
Okay.
Because the word itself is misleading. When most people hear the word ash, they picture a campfire.
Right,
They
exactly.
picture gray, flaky carbon remains from burnt wood or paper.
Yeah, because we associate the word with something that has been entirely consumed by fire.
Right. But in human cremation, whether it's by flame or by water, the soft tissue doesn't turn into ash. In a flame crematorium, the soft tissue vaporizes.
It just goes up the stack.
Exactly. The only thing that physically survives the 1400-degree heat is the body's skeletal system, the inorganic bone matrix.
So when a family receives an urn from a traditional cremation, they aren't receiving the ashes of the skin or organs, they are receiving pulverized bone.
Exactly. The skeletal remains are swept out of the furnace, they're mechanically pulverized into a coarse powder, and that powder is what the industry calls cremated remains, or ashes.
Okay, I see.
Now, apply that same logic to aquamation. The alkaline water dissolves all the soft tissue, just like the fire vaporized it. So what remains at the bottom of the stainless steel vessel when the liquid is drained?
The bone matrix.
Yes, the calcium phosphate of the skeletal system. The process leaves the exact same core material behind.
I see. So the operator takes those remaining bone fragments, dries them out, and pulverizes them into a powder, just like the traditional method. So the physical return is functionally the same.
Functionally the same, yes, but aesthetically and texturally, the differences are striking.
Really?
Yeah. The guide from the funeral program site emphasizes how different aquamation ashes look. They are incredibly fine, almost like powdered sugar or fine sand,
Oh, wow.
and they're usually pure white.
Pure white, because there is no carbon charring.
Exactly. Think about the harshness of a 1400-degree flame. Fire chars, it discolors.
Yeah, of course.
Traditional cremated remains are often gray, dark, or kind of rough because the bones literally baked in carbon and intense destructive heat.
That paints quite a picture.
But in aquamation, the bones rest in a warm alkaline liquid that gently washes away all organic material. It leaves the calcium phosphate completely clean, completely uncharred.
You know, that physical difference plays really heavily into the profound psychological shift we mentioned earlier.
Oh, absolutely.
The guide notes that families consistently use words like peaceful, gentle, and calming to describe the aquamation process.
It's a very different vibe.
And when you look at the deep psychological archetypes of humanity, it makes perfect sense. Fire is universally destructive. It is a violent, consuming force. We instinctively associate fire with pain and punishment.
Even though we rationally know that a deceased loved one feels no physical pain, the mental image of pushing them into an industrial furnace is, well, it's inherently traumatic.
It is. But water is the exact opposite. Water is maternal. It is the beginning of life. We associate warm water with healing, with washing, with baptism, with spa treatments.
Right.
So when a grieving family hands over their mother to an aquamation facility, they aren't imagining her burning. They are imagining her resting in a warm, gentle bath that quietly dissolves her physical form.
Yeah?
It shifts the entire paradigm of the final goodbye from one of violence to one of returning to nature.
That mental image provides immense psychological comfort during a period of acute trauma. You are taking a clinical chemical process, alkaline hydrolysis, and allowing it to fulfill humanity's deep-seated need for ritualistic cleansing and a peaceful transition.
Which makes the science beautiful.
It really does.
But if we were being totally intellectually honest about this process, we have to look at the mass that doesn't remain as bone.
Yes. The rest of it.
Right. A human body has mass. If a 180-pound person goes into the chamber and the family receives perhaps 6 to 8 pounds of pulverized bone back, what happens to the remaining 170 pounds?
We definitely have to talk about the liquid byproduct.
Yeah, because this is where the critics strike, and it brings up a very visceral yuck factor that we really need to wrestle with here.
It is absolutely the most common point of resistance. Once the cycle is complete, you have the bone fragments and you have the effluent, the liquid byproduct.
Okay.
And as we established earlier, this liquid is entirely sterile.
Because the heat, the pressure, and the high pH unspooled all the DNA, killed all viruses, and destroyed any prions.
Exactly. The liquid is functionally a mixture of 95% water and 5% organic building blocks.
Like what?
Amino acids, small peptides, sugars, and salts. It is a highly nutrient-rich, entirely safe solution.
But where does it go?
Well, in the vast majority of municipal setups, it is released directly into the municipal wastewater treatment system.
Okay, I have to admit, even knowing the science, my brain pushes back on that.
It's a normal reaction.
There is a deep psychological yuck factor to the idea of a loved one's liquefied remains being flushed into the city sewer system. It feels, I don't know, undignified. It feels like industrial waste.
Your reaction is entirely normal, and it is exactly the reaction the critics of aquamation weaponize.
I can imagine.
They will go to city council meetings and use highly charged rhetoric. They will say things like, "We are flushing our grandparents down the drain," or they want to pump human bodies into the municipal water supply.
Which sounds horrific when phrased that way.
It plays entirely on emotion, but it ignores two major realities.
Okay, what's the first?
First, it ignores the biological reality of what the liquid actually is. It is not a body. It is sterile amino acids and salts.
Right, it's just molecular building blocks at that point.
Exactly. And second, and more importantly, it ignores the current, accepted reality of the traditional funeral industry.
What do you mean?
Well, what do you think happens to the blood and bodily fluids during a traditional embalming process?
Oh, right. If a traditional funeral home prepares a body for an open casket viewing, they replace the blood with embalming fluid.
And where does that blood go?
Oh, wow.
It goes straight down the drain into the exact same municipal wastewater system.
I never thought about that.
But traditional embalming doesn't just release biological fluids. It releases massive amounts of formaldehyde, methanol, and other highly toxic carcinogenic chemicals directly into the sewer.
So the traditional industry has been utilizing the municipal wastewater system for a century to dispose of raw bodily fluids mixed with literal poison.
Yes. And the municipal water treatment plants, they are designed to handle high biological loads. They process human waste, agricultural runoff, industrial chemicals 24 hours a day.
Right.
The sterile, nutrient-rich effluent from an aquamation facility is vastly safer and easier for a municipal plant to process than the toxic chemical runoff from a standard embalming room.
That completely flips the perspective.
It really does.
So the yuck factor is purely a public relations problem, not a scientific or environmental one.
Exactly.
But that PR problem spills over into religious and legislative arenas, doesn't it? The guide highlights that several major religious institutions have raised theological concerns about the dignity of the process.
Yeah, and we're really watching history repeat itself here.
How so?
In the late 19th and early 20th centuries, the rise of traditional flame cremation faced fierce opposition from major religions.
Oh, really?
Oh, yeah. There were profound theological concerns about the resurrection of the physical body, and burning was historically associated with desecration or punishment.
That makes sense.
It took decades of theological debate, cultural shifts, and patient education for many major faiths to eventually evolve their stances and accept flame cremation.
And now flame cremation is the most common form of disposition in the country.
Exactly. Aquamation is at the very beginning of that exact same adoption curve.
Right.
Religious institutions inherently move slowly. They prioritize tradition and establish ritual. They are actively wrestling with how to reconcile this new technology with their ancient texts.
Which underscores why the educational material from the funeral program site is so vital.
Absolutely.
Because if a community believes a local business is melting bodies in acid and dumping them in the sewer, because that is the narrative critics will push, they will ban it.
In a heartbeat.
But if the community understands the science of sterile alkaline hydrolysis, the massive reduction in carbon emissions, and the reality of how wastewater actually works, the fear just evaporates.
But even with perfect education and community acceptance, There is another massive barrier preventing you from just, walking down the street to your local funeral home and requesting the service.
The legal and infrastructural reality.
Yeah.
If this is so clearly superior in terms of sustainability, why isn't it available everywhere right now?
First, we have to look at the legal definition of cremation. In many states, the laws governing funeral homes were written 50 or 60 years ago,
Okay.
and the legal code explicitly defines cremation as a process involving direct flame, combustion, or incineration.
So, purely by a quirk of historical semantics, aquamation is technically illegal in those states simply because it doesn't use fire.
Precisely. It doesn't meet the legal definition. So to offer aquamation, advocates have to lobby the state legislature, endure committee hearings, and pass new bills to legally redefine cremation to include alkaline hydrolysis.
And that is a slow, grinding, bureaucratic process.
Very slow.
But what about the states where it is fully legal? Why isn't every funeral home rushing to install these machines?
Economics and inertia.
Economics.
Yeah. The traditional funeral industry is built on massive sunk cost infrastructure. A traditional funeral home has hundreds of thousands of dollars invested in crematorium retorts, which are the actual furnaces, along with embalming stations, ventilation systems, and specialized staff.
And I imagine a commercial-grade stainless steel pressure vessel capable of safely handling a pH 14 solution at 300 degrees is not a cheap piece of hardware.
Not at all. It is a massive capital investment. An alkaline hydrolysis machine can cost hundreds of thousands of dollars. But the machine is only part of the cost.
Yeah.
You can't just plug this into a standard wall outlet and run a garden hose to it.
Right, you are dealing with high-pressure plumbing, precision chemical mixing, and massive volumes of water.
Exactly. You have to totally retrofit the facility. You need specialized plumbing, capable of handling high alkalinity without corroding.
Oh, wow.
You need advanced wastewater connections that meet strict municipal flow rate regulations, ensuring you don't overwhelm the local sewer system with a sudden discharge of heavy liquid.
That makes sense.
You need specialized drainage, reinforced flooring to hold the immense weight of a water-filled chamber, and you have to retrain your entire staff on pressurized chemical safety.
It makes me think of the automotive industry's transition to electric vehicles.
Oh, that's a good comparison.
Because if you have a mechanic who has spent 40 years running a shop dedicated exclusively to internal combustion engines, changing oil, fixing spark plugs, managing exhaust systems, and you tell them the future is electric, they might agree with you.
Sure.
They might know EVs are cleaner and more efficient. But the upfront cost to retrofit their shop, install high-voltage diagnostics, rip out the old lifts, and completely retrain their staff is an intimidating, often insurmountable mountain to climb.
It is a phenomenal analogy. The small, independent funeral director simply may not have the capital to abandon their functioning flame crematorium to invest in the unproven market of aquamation. The inertia of the established system is incredibly heavy.
But the guides strongly suggest that consumer demand is going to force their hand eventually, because aquamation isn't operating in a vacuum. It is part of a rapidly growing, overarching cultural shift called the Green Death movement.
Yes. The paradigm of how we view our relationship with the earth is shifting. For over a century, the standard American funeral was essentially an act of environmental defiance.
Environmental defiance, I like that phrasing.
It really was. We drained bodies of blood, pumped them full of toxic preserving formaldehyde, placed them in heavy steel caskets, and lowered them into thick concrete vaults. We essentially created highly toxic, permanent underground landfills that take up valuable real estate forever.
Or, alternatively, we utilized massive amounts of fossil fuels to blast carbon into the atmosphere.
Right. The Green Death movement looks at both of those options and says, we have to do better. People are demanding sustainability in their final act.
So what else is part of this movement?
Well, we are seeing a surge in green burials, where unembalmed bodies are placed directly into the earth in biodegradable shrouds to return nutrients directly to the soil.
Oh, wow.
And we are seeing the legalization of human composting, natural organic reduction, which turns a body into a cubic yard of rich, usable soil in just a few months.
Aquamation fits perfectly into this new ecosystem of choices then.
Perfectly.
It appeals to the person who wants the convenience, the conceptual idea of cremation, receiving ashes back to scatter or keep, but who refuses to leave a massive carbon footprint on their way out.
It is all about working in harmony with the natural order.
Hmm.
Whether it is soil microbes in human composting or the natural solvent of water in aquamation, these new methods prioritize returning to the ecological cycle without poisoning the earth or burning its resources.
Yeah.
And as more families educate themselves through guides like the one provided by the funeral program site, the demand for these services will eventually outpace the funeral industry's hesitation. The market will adapt because the consumer will just refuse the toxic alternatives.
We've covered incredible ground today. We started with a concept that, on the surface, sounded coldly industrial: alkaline hydrolysis.
Yeah, quite a journey.
We walked through the rigorous chemistry of pH balances, the cleaving of peptide bonds, and the destruction of prions that guarantees a perfectly sterile outcome.
We contracted the staggering thermodynamic cost of maintaining a 1400-degree inferno against the elegant efficiency of a pressurized water bath, revealing a massive reduction in greenhouse gas emissions and the elimination of airborne particulate pollution.
We broke down the misconception of what ashes actually are, discovering that water leaves the exact same bone matrix behind, but gently washes it pure white rather than baking it in carbon and char.
We confronted the psychological yuck factor of the liquid byproduct, realizing that municipal wastewater systems are vastly better equipped to handle sterile, nutrient-rich amino acids than they are the toxic embalming chemicals the industry currently flushes away every single day.
And we recognize that while ancient legislative wording and massive infrastructure costs are currently slowing the widespread adoption of aquamation, the cultural demand for sustainable green death alternatives is ultimately unstoppable. Education truly is the catalyst here.
It really is.
When people understand the science, the fear of the unknown is entirely replaced by the comfort of a gentle return.
It is a profound shift. We are witnessing the reinvention of one of humanity's oldest rituals, guided by both cutting-edge science and a renewed respect for the earth.
Which leaves us with a truly fascinating idea to consider as we wrap up.
Let's hear it.
For a century, our final defining act on this earth has been one of consumption. We have demanded permanent real estate, taking up land with concrete and steel vaults that will outlast civilizations. Or we have consumed massive amounts of fossil fuels, burning energy to forcefully remove ourselves from the biological cycle.
Yeah.
But if aquamation, green burial, and natural composting become our new cultural baseline, what happens to our collective legacy? When our final act is no longer about stubbornly taking up space, but rather about seamlessly, quietly dissolving back into the natural ecosystem, does it fundamentally alter the human ego? If we embrace the reality that we are meant to gently wash away, does changing how we leave the earth ultimately change how we view our importance while we are living on it?